Let's learn about acceleration. Here's our objectives. Imagine you're in a car with your friend and she tells you to accelerate. What exactly does she mean? Well, she probably means speed up. But that's not what it really means. Acceleration is any change in speed or direction. An acceleration is like a push, which causes objects to speed up, slow down, or change direction. And acceleration is made up of 3 units. It's the change in speed over time. I have a car that is so fast. It goes from 0 to 60 miles per hour. Well, that's not enough info. We need to know how many seconds it takes. A good description of acceleration would be it goes from 0 to 60 miles per hour in 5 seconds. Some accelerations are positive. For example, a motorcycle accelerates from rest to 32 meters per second east in 4 seconds. What's the motorcycle's acceleration? Using the acceleration equation, we can plug in the initial velocity, final velocity, and the time, and see the motorcycle accelerates at 8 meters per second every second, which is 8 meters per second, or 8 meters per second squared. If the motorcycle is accelerating at 8 meters per second, or 8 meters per second squared, then how fast will it be moving at each second? Well, it starts at 0 meters per second, and then speeds up to 8 meters per second, then 16 meters per second, 24 meters per second, and it will reach 32 meters per second after 4 seconds, just like we calculated. With this same acceleration, how fast will the motorcycle be moving after 5 seconds? It'll be going 40 meters per second. Can you predict how a negative acceleration would affect an object with a positive velocity? Another motorcycle is traveling at 26 meters per second east, and it experiences an acceleration of negative 6.5 meters per second squared. How long will it take for the motorcycle to stop? Plugging in the acceleration, initial, and final velocities, it will take 4 seconds for the motorcycle to come to a complete stop. So a negative acceleration slows down an object with a positive velocity. What will be the speed at each point when it's going 26 meters per second with an acceleration of negative 6.5 meters per second squared? Well, it starts at 26 meters per second, slows to 19.5 meters per second, then 13 meters per second, 6.5 meters per second, and after 4 seconds, the motorcycle will come to a complete stop. Can you predict how a negative acceleration would affect an object with a negative velocity? Do negative accelerations or pushes always slow down an object? No, not if the object is moving in a negative direction, such as south, west, down, or left. Now we come to one of the classic questions in physics. Which will fall faster from the top of a building, a bowling ball or a golf ball? While I've heard explanations for both, the bowling ball falls faster because it has more mass. No, the golf ball falls faster because it has less air resistance. The truth is, they both fall at the same rate and will hit the ground at the same time because they are in free fall, which are objects in the air that are only affected by gravity. But what about a hammer and a feather? It's still true. Without air, they hit the ground at the same time, and you can watch a NASA video that shows this happening on the moon. Pretty amazing. All objects in free fall on Earth experience the same acceleration due to gravity, which is negative 9.8 meters per second squared. With this value, we'll now introduce some new equations. These accelerated motion equations can help us solve a wide variety of questions. An apple falls from the top of a 6-meter tree. How long will it take to hit the ground? So one of the challenges in physics is recognizing the information given in a problem. We see the distance it falls is 6 meters, but what else do we know? Well, we also know that it experiences an acceleration of negative 9.8 meters per second squared because it's in free fall, and it's understood that it's at rest at the top of a tree, giving it an initial velocity of 0 meters per second. Since we know the acceleration due to gravity, the initial velocity, and the distance, which equation should we use to solve for time? Well, the one in the upper left-hand corner is only for average velocity, not accelerated motion. So we should choose this one. By filling in the distance, the initial velocity, and the acceleration due to gravity, we can see it'll take 1.1 seconds. So it takes 1.1 seconds for an apple to fall from a 6-meter tree. In free fall, without air resistance, how long would it take a heavy cannon to fall from a 6-meter tree? All objects on Earth will take 1.1 seconds, since they all accelerate at negative 9.8 meters per second squared, as long as they don't have rockets or wings. And this example shows how a negative acceleration can cause objects to speed up.